Good morning, ladies and gentlemen. I am Prapaporn Prasathpong, a lecturer from Department of Mechanical Engineering, Rajamangala University of Technology, Thanyaburi, Thailand. Today, I will present my research on densification of corn residue for producing pelletized biomass fuel. My presentation is divided into 5 main parts. First, I will talk about background of biomass densification and the rationale of this research. Then, materials and methods. Third, results and discussion. Fourth, conclusions. And finally, recommendation for future study. Let's start with background. Continual growth in energy consumption, greenhouse gas emission, and environmental problem from combustion of fossil fuel is alarming, and it has raised sustainable energy research to be among top priorities. Agricultural residue, as the major byproduct of agriculture, is one of the most important biomass resources, with excellent energy potential and in many countries. Corn is one of the important agricultural crops in many countries. Its cultivation and harvesting provide a huge amount of corn residue that are potential biomass feedstock for fuel production. Normally, this corn residue, such as cobs, husks, leaves, and stalks, were left in the field and consequently disposed of via burning, which create air pollution that affecting human health and environment. This residue can be utilized for heat, power, and fuel production. However, the low energy density affects its storage, transportation, and uses. Densification can be applied to improve its property and enhance its utilization. Densification of corn residue has been studied by many research groups. However, for densification of corn husks or peels, which were normally attached to corn cob, had rarely been studied. Hence, study into conversion of this specific corn waste to high-quality fuel is of interest. So, the objective of this work is to study densification of corn cobs and corn husks using a pellet mill. In this study, corn cobs and corn husks were used as the raw material. They were torn off with a shredding machine, then further ground using a disc mill to obtain the particle size less than 3.0 mm. Both ground corn cobs and corn husks were dried in a solar-powered greenhouse dryer until their moisture content was reduced to about 9% dye resin. Then, the sample material were prepared for 5 different initial moisture content by adding predetermined amount of distilled water and thoroughly mixed. The pelleting process was carried out in the fat die pelletizing mill with 8 mm diameter holes and initial die temperature of 80 degrees Celsius as shown in the figure. In the typical run, 5 kg of sample was fed into the pelleting machine. Then, the pellets were dried out using the solar greenhouse dryer for at least 3 days to reduce the moisture content. For property analysis of pellet, 400 grams of each dry pellet for each run were utilized. The length of the pellets was measured and classified into different ranges. The bulk density and property of the pelletized corn cob and corn husk were analyzed. For pellet formation, corn cobs pellet can be successfully formed at the moisture content of 10 to 20%, while formation of corn husk pellets was occurred at the moisture content of 15 to 30%. Increasing in moisture content from 10 to 20 result in increased pellet yield for both materials, while the further increase in moisture gave negative effect on the densification of corn husk. For pellet length, corn husk pellets were shown to have higher yields of formed pellet for all lengths at the same initial moisture content. For the pelletized corn cobs, the highest yield of the formed pellets and the longest pellet lengths in the range of 30 to 40 mm were found at the initial moisture content of 20%. And most of pelletization of corn husk provide short length of pellet for all initial moisture content. The highest yield for the formed pellets was also found at the same initial moisture content at 20%. For bulk density, corn husk pellets have higher bulk density than corn cob pellets. The maximum bulk density for both materials was found at the initial moisture content of 15%, which is 232 kg per cubic meter for corn cob pellets and 304 kg per cubic meter for corn husk pellet. For proximate analysis and heating value of pellet, it was found that pelletized corn husks have slightly higher heating value than corn cob pellet, which higher than standard, and the moisture content for both pelletized corn cob and corn husk are in the range of the expected value mentioned in the standard. For conclusion, corn cobs and corn husks were successfully formed via densification at the initial moisture content in range of 15 to 20% with maximum bulk density of 304 kg per cubic meter. For recommendation, binder adding and process parameter adjusting should be studied to improve the field quality of pellet. This work was supported by new research grant, National Science and Technology Development Agency, Rajamangala University of Technology Thanyaburi, Chiang Mai University, and University of Phayao. Thank you for your attention.